All right, in number 17, they tell us in the figure below, AB is parallel, that's the symbol, to CD. So we know that these two lines are parallel. And whenever you see about parallel lines, you're going to want to imply all of the different types of angles that you learned about parallel lines. We want you to assume all of those because they're telling you they're parallel. And for each of these problems, A, B, C, D, and E, they're asking us to decide whether or not, based on this information, based on these two lines being parallel, do we know that any of these things are true? So let's look at the first one. They want us to know, is triangle EAB similar to triangle ECD? Now you will remember, hopefully, that triangle similarity is kind of like triangle congruence. So you've got your side angle side, your side side side, your angle side angle, and you also have an extra one. You have angle angle, or angle 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 if you really want to call it that way, which said that if all of your angles were congruent, then the triangles could also be similar. So let's look at this. We've got these parallel lines EAB, which tells us that the corresponding angles between these are congruent. So angle EAB, this angle, is congruent to angle ECD. They're corresponding on these parallel lines because they're both on top of the line on the left hand or the right hand side of this transversal that cuts it. We also know that angle EBA, this angle right here, is congruent to EDC, this angle right here, for the same reason. They are also on top of the parallel lines, but now they're on the left hand side of this transversal ED. So yes, we do know that EAB is similar to ECD because of angle angle. So I'm going to highlight the ones that are true. All right. Let's move on to the next one. They want to know, is EA over EC equal to EB over ED? And so this is basically comparing parts of the triangle. It's a proportional statement, and we need to decide if they put the right letters in there. So they want to know if EA, this side, over EC, this side, goes with EB, this side, over ED, this side. I would say yes, that proportionality statement is true because this is top left over whole left hand side equals top right over whole right hand side. And we know by the side splitting theorem that that is true. So B is true as well. All right, let's look at C. We've got EA over AC equals EB over BD. All right, EA, that's already in yellow, over AC, that's this bottom part right here, AC, equals EB, that's already in yellow, over BD. So this is top left over bottom left equals top right over bottom right. And yes, again, I would say that that is true. So C is true as well. Now they want to know, is EAB isosceles? Is EAB isosceles? The whole time we've been talking, have we said anything about sides? No. And these angles at the bottom, EAB and EBA, those aren't necessarily congruent. And if they're not congruent, then we don't know, then that means that the triangle cannot be congruent. So this is not true. False. D is false. All right, part E. AB equals half of CD. Here's AB, here's CD, and they want to know, is AB half of CD? Now we did learn about how this segment in the middle could be half of the bottom. And that was basically talking about the median of a triangle. And a median of a triangle is equal to 1/2 of the base. Now a median has to touch the middle of all of the sides. So do we know that EB is equal to BD? Or do we know that EA is equal to AC? If we did, then that would be true. But right now we do not know that. If EA is equal to AC, then AB is a median. But if it's not, then that's not true. So we're going to go back and say right now, that is false. We do not have enough information for that one.